What this tutorial is, let's just jump into it. It's about a very specific, narrow aspect of Python 3 programming. And I personally consider it to be the most important part of Python 3 of all, which is the complete re-implementation of the I/O system. So if you have not used Python 3, you may not realize that that I/O, all the way from like operating system interfaces all the way up, has been rebuilt in this version of Python. And the reason why I'm interested in this is that real programs, as far as I'm concerned, interact with the outside world. I mean, you read and write files, you send and receive network messages. I don't know of any like real programmer who's just sitting around like doing Fibonacci numbers and stuff. I make it my mission to bash Fibonacci numbers in every class now. So, you have this I/O is basically at the heart of a lot of reasons why people use Python. And all of a sudden, Python 3 comes along and re-implements it. So that's kind of, that's an issue that's going to come up. And one of the things that I noticed is in updating my book over the last year, I mean, I spent a lot of time kind of in the guts of Python 3, looking at library modules, looking at code that would work in different versions. I actually found this I/O business to be the most problematic aspect of it. It's not like little syntax changes. I mean, that's kind of like minor league stuff. It's basically I/O that is really a big problem. And one of the problems is that these I/O issues can't be fixed by the 2 to 3 conversion tool. So we're going to see that in a second, but a lot of the things that we're going to talk about, not only are they a problem, but they can't be fixed by this automatic converter. So what we're going to do in this tutorial is I'm sort of treating this as like basically a top to bottom tour of the entire I/O system in Python 3, assuming that you've like never seen anything about it. It's almost like a from scratch. If I were going to explain to a new programmer, how does I/O work in Python 3? That's what we're going to do here. So we're going to look at a bunch of things like how to handle text, how to deal with binary data, system interfaces, and then some of the more advanced features at the end. And then as far as some prerequisites, I do assume that you're generally familiar with I/O in Python 2. I mean, I'm not going to do like huge numbers of comparisons, but you should know about like a little bit about strings and Unicode and print and open and the library and so forth. I do not actually assume that you know anything about Python 3. Which, based on my little survey earlier, is probably a good thing for this tutorial. And then just in the interest of a little bit of disclosure, I do some performance tests every now and then. This slide just has the platform that I did those tests on. I actually don't mean for this tutorial to be like a big performance study. So any number that you see should just be kind of, view it as like a rough estimate. Might change on your own machine a little bit. So we're just going to jump into it. I did put up a web page. It has just some support files. I mean, you can kind of look at them if you want to. I would say that this tutorial is not really heavily geared at like programming stuff. So we're not going to build like a huge application or anything. A lot of what we're going to do is just like little short examples of like, well, look at this aspect of Python 3. What you may want to do if you haven't installed Python 3 is to download it, install it, maybe kind of play with it as we go along. And the other thing, if you have questions at any time, just jump in and raise your hand. And we'll talk about that. So hopefully I'll get people kind of stirred up as we go. So are there any questions about anything before we jump into it? Yeah, question.
In your explanations, are you going to explain why it was changed?
So the question is, am I going to explain why it's been changed? I hope so. So if I don't, then I will have like failed in some way. So yeah, hopefully I'll be able to do that. Just so you know, I mean, I actually think there's some really great stuff going on in Python 3. Part of what this tutorial is about is actually an attempt to maybe expose some of that to the outside world a little bit more, because I think there's some pretty surprising things going on that just they're not really widely covered in like the What's New guide very well. So in this part one, Let me just talk about the really obvious stuff that you probably already know about Python 3. First of all, you probably know that Python 3 changes syntax. I mean, this is kind of the thing that everybody focuses on when they first introduce it. It's like, okay, print breaks. And there's like some other little syntax things like, exception handling. You have to put this as, like keyword, in between the exception type and the value. Okay, so like little minor superficial things break going from Python 2 to Python 3. Some other things, there's a lot of new language features in Python 3. There's like a new string formatting. We're actually going to talk about that one a little bit more. There's things like dictionary comprehensions. There's function annotations. I mean, you could go through like an entire tutorial of just like cool language features. Actually, maybe I suspect that Wesley is going to talk about this in his talk. It's on Friday. Friday is the Python 3 talk. But we're not really going to do that here because that's like a totally different subject. Some other things that have changed is some of the built-in functions have actually changed slightly. So things like range and zip behave slightly differently in Python 3 than they do in Python 2. Most of the changes that you find here are sort of tied into things like iteration and generators. So instead of zip making like a huge populated list of results, it now returns sort of an iterator that will give you results. And then some things changed in the library. A lot of the standard library got sort of cleaned up and reorganized. So mostly where you see this is in some of the networking and internet, network internet stuff. So things like URL, lib2, and HTTP, and all those libraries have kind of been reorganized and put into more of a package structure. So that's the kind of thing that you see if you move to Python 3 is this sort of library reorganization and some new language feature. One thing that I'll just comment, having done this, the book update of the essential reference, the standard library in Python 3, for all practical purposes, is virtually identical to Python 2.6. The only difference really between the two is that the names of the modules in Python 3 have like shifted around a little bit. So that's one thing to keep in mind about those two versions. Is the standard libraries are really, really, really similar to each other. Now, another thing about Python 3 you may know about is this 2 to 3 tool. In doing in porting to Python 3, you often hear about this tool, 2 to 3, that you can run on your program, and then it will identify things that you need to fix to get it to run into Python 3. If you've never used this before, it's essentially a command line tool that you just run on your program. And kind of the way that this works, I'll just show you a little quick sample. So this is actually it's kind of a dumb program really, but it's just a program that fetches a web page and then just looks for all the href A tags and then just prints out all the links. So this is a little program, uses HTML parser, probably not the best choice, but it's in the standard library, uses URL open. If you were to run this program, pretty sure I have it here. So you just say Python print links.py, and then you give it, some URL. So let's see what happens here. Let's see if it actually works.
You're a little off the screen. Can you pull your window down?
Am I off the top of the screen?
Yeah.
Okay. Okay, so we'll see if it works. Okay, so if you run it, it generates kind of a list of just links there. If I try to convert that with this 2 to 3 tool, so let's say I wanted to port this to Python 3, the way that it works is you would just in the Unix shell you would just type 2 to 3 print links, and then it comes back and shows you a diff of what you need to change in your program. So if I were to do that, here, if I'd say 2 to 3 print links.py, it will go through that, and then it sort of shows you the lines that you need to fix up. So up here at the top, it's telling you, okay, URL lib got shifted around. Yeah.
Can you move it a bit to the right? That's perfect.
Okay. Where is it cutting off, by the way?
Left.
Is it by the terminal or is it by the?
Move down half a centimeter.
Yeah.
So am I missing like everything above that window and everything to the left of the window? Okay. Okay, so I should shift things way over here. Okay, so actually that window there is from the Django tutorial this morning. Okay, so if you run this, you'll see that it's, it says, okay, you got to fix URL lib, got changed around, and it tells you what you need to change. So, it's fixing up some module imports. Here it's saying, oh, hey, if you're going to use print, you got to change it into a function. So it's showing you that. And then it fixes up a few other things. Down here at the bottom, it decides, it's sort of patched up the URL open to kind of reflect its new location and so forth. And so if you just run this normally, all it does is produce this diff. It doesn't actually modify any of your code or anything. If you run 2 to 3, it just sort of says, hey, well, this is what you need to fix if you want to do that. If you're feeling really lucky, I think it's -W that will do that. You can say -W print links, and it will go through and rewrite the source file with the result. I'm not even sure that makes a backup unless you tell it to. So if you were to do that, it's essentially, if you look at the code, it's been modified to run in Python 3. And if you're really lucky, maybe it will even work. So you could say, if I go back to my command here, I could say Python 3 print links, and maybe it will actually run. It turns out that it does not run in this case. So if you try this, you'll get a program that is sort of syntactically correct Python 3, but it doesn't actually work. The reason that it doesn't work is that there's an I/O handling problem in the code that 2 to 3 did not find. It turns out that, okay, so you get this message saying can't convert bytes to an str. What's going on here is that the URL open is returning byte data, but HTML parser is working with Unicode text, and the two do not match together in Python 3. So the takeaway on that is that 2 to 3 does not find everything that's wrong with your code. I think that's like the one big takeaway on that tool, is that if you're working with a big project and you're trying to do this port to Python 3, there is a tool that can find things like module names, it can find syntax, it cannot find like little subtle like semantic things like that. So you can actually fix the program. If you want to fix it, you have to go in and manually do some kind of decode operation, saying, well, I want to decode that data that I got off the web as UTF-8. Then I can go in and like have the program run. So some lessons on that before we jump into the I/O stuff is that a lot of things change in Python 3, but this 2 to 3 tool does not find everything. So you could imagine maybe the difficulty in applying this to like a 100,000 line program. Actually, I don't even really want to think about that, but you could imagine the difficulty there. So any questions about that before we jump a little bit further? Just out of curiosity, I mean, admittedly, not too many people said they'd ever used Python 3. How many people have actually ever used 2 to 3 on anything? How did it work out? What was your experience with it?
Pretty much like what you just showed.
Okay. And you did, is that also what?
It was like 50-50.
About 50-50? Okay. Yeah, I don't find that, and was it like I/O things that?
I can't really recall what it was that broke, but kind of it really depends on the complexity of the program.
I had the I/O because I was looking at a lot of files.
Okay, yeah.
They stuck out immediately.
So yeah, I definitely think this is this is going to be an issue for people who have to port. That it doesn't find everything that you might expect. So what we're going to do in this part 2, we're going to start just kind of from the beginning and take you on a tour of Python 3 I/O. And this first part is actually going to be about text processing in Python 3. So one thing that you're going to have to do, and actually I'm just going to walk around front because I want to see where this is cutting off on the... Okay, a little bit off the top there. You want to pull it forward a little bit? It's kind of weird not being able to see the screen as the presenter there. Okay, that's a little better. Okay. So one thing that you're going to have to do in Python 3 is you're going to have to make peace with Unicode in some manner or another. I might get a higher percentage of responses here, but I mean, how many people here actually, do a lot with like Unicode text processing into it? The reason I ask is I do a lot of Python, like classes, over the year, and I rarely run into programmers that do Unicode stuff. Now, partly that's because I do a lot with scientists and engineers. So, people doing like, physics simulations, they don't really care about Unicode at all. I mean, they like prefer not to talk about it. Yes?
Not in the United States.
That's also, yeah, it's also a cultural bias. I will admit that. It should be enough for everybody. Yeah. ASCII is good enough for everybody. I have this slide. I mean, this Unicode stuff is something you have to embrace or at least tolerate if you're going to go to Python 3, because a major thing in Python 3 is that all text, all strings are now Unicode in the language. So it isn't something that you can really live in denial about anymore. And so what I want to do here is actually just talk about some very essential details of Unicode that people need to know about, even if you don't care one bit about Unicode. So we're going to talk about just a couple of details. I did not hopefully bill this tutorial as like an internationalization tutorial, so we're not going to go completely off the deep end with it. So first thing to know is that most old school programmers do know about ASCII. If you're really geeky like me, I think I almost had like the whole ASCII code chart memorized at one point, where it's like, oh yeah, 4F, that's probably like, M or something like that. So if from ASCII that every character has its own integer code associated with it, and strings are just sequences of these character codes. Okay, so you're familiar with that already. At a very superficial level, Unicode is just that same idea. The main difference is that there's a huge number of codes. So at a very high level, Unicode assigns an integer code to every single character used in all languages. I mean, that's kind of the idea behind it, except for things like Klingon. Although I think there is like an unofficial Unicode Klingon code set somewhere. And so these codes, they're sort of known as a code point, and sometimes you see them written out in conversation as hex numbers. So you might say U plus 00F1 indicates some character code value. If you want to know what these codes are, the place to go is this unicode.org charts. That will actually let you explore through the Unicode character set, so you can see what the different characters are if you're interested in that. So you'll get to a website that sort of looks like that. If you want to browse around and see what's there, you can do that. But from a more practical standpoint in Python 3, one of the things that you're going to see is that Unicode characters can now actually start showing up almost everywhere. So one of the things that you need to know how to do is actually how to indicate characters in source file. So one of the things that you can do is it turns out that Python 3 is actually aware of Unicode characters directly typed into source code. So if you're in the in the Python 3 interpreter, I'm going to pull it up a little bit here. You can actually directly type Unicode characters, if you know how, directly into the code. So if I want to type out spicy jalapeno, I can just type it directly in there with the you can maybe see the Unicode character N there. And so you can type things into the program. Another thing that you can do, actually I'm going to make the size a little bit bigger here, real quick. Okay, so you can see the character there. Python 3 lets you make variable names with Unicode characters. I don't think it's necessarily a good idea, but if you want to say pi is equal to 3.14, you can do that. if you have the right tools, like you may not know about this on the Mac, you can turn on like the character viewer. Might take a second to come up. It actually, it's going to be impossible to see in the back. I apologize for that, but you can browse through the different like Unicode characters, and it will actually let you even type these directly into like your program. I don't even know whether that's like a valid. Okay, it's valid. So like if you wanted to like annoy the hell out of your coworkers or something like that, you could, insert variable names that are Unicode characters. Again, I don't think I would advocate that as like a general programming policy, but you can do that in Python 3. And then as far as if you can't type things, at least in strings, you should know about these escape sequences that people use. So there actually are, there's actually 3 different escape sequences that you might embed in a string to do a Unicode character. You can use this \x to just do like a byte value. If you get to larger values, you use \_u. And then if you need to do a really large Unicode character, you do \U with 8 hexadigits to specify that. I don't know how that jives with the Zen of Python, with the lowercase u versus the uppercase u, but that's actually different ways of embedding characters into a program, is to use those. I've chosen, I think, the Planck's constant over here to try and get physicists on board with Unicode a little bit, So that's how you write Unicode characters. Another way that you might do it, if you go exploring some of these Unicode charts, I don't know how many people know about this, but all the letters actually have a descriptive name, like small Latin letter N with tilde. If you do a \N and then put that name in curly braces, it will actually pick that out and put it in your string. So. Yeah, that's how you would make that very verbose. Actually, if I pull up that character viewer again, it actually shows you those names. So you may not be able to see it in the back, but like this letter here, it says it's Tamil letter 1 or letter. Maybe that's an I, depending on the font. You could actually use that name, and it would embed it into a string. Very verbose, admittedly, but you can do that. And then as far as other things with Unicode, I actually sort of advise people don't overthink it. It is these Unicode strings. They are mostly like ASCII strings, except that you now have like this huge range of codes for characters that you can put in there. And in fact, everything that you do with these strings, like stripping and finding and searching and all that stuff, that is all going to work just fine with Unicode, except you have to have this now. You have this much greater range of codes to work with. Now, I do need to make you aware that saying Unicode like ASCII. I've probably committed like some huge egregious faux pas in the Unicode community for saying something like that. You really need to be aware that Unicode is like ASCII, except when it's not like ASCII. And this is not the only example of this, but this is one subtlety of Unicode. It turns out that many of the characters actually have 2 different representations that they might show up as. So like this, in jalapeno, the N with the tilde, it could be code F1, or it could be the letter N with a combining tilde character applied to it. So you can actually have like 2 different strings that have totally different Unicode characters in them, where if they were printed out, this is kind of interesting in Python 3, if you look at the values, it basically says, well, S is jalapeno and T is jalapeno, but if you do an equality check, they're false. And it's like, okay, my head just exploded with that. There's a lot of tricky details like that if you get into like an internationalization tutorial. So if you're dealing with like websites, you need to take like usernames and do things like that. You do have to get into these issues of like how do you normalize strings to have one representation and so forth. We're not going to go further into that here because I don't think it'd be that interesting, and that isn't really the point of this tutorial. But that is something something to keep in mind. So before I go further with that, I mean, are there any questions about that so far? Yeah, question in the...
Oh, does that primarily mean making UTF-8 strings?
Unicode is essentially these. I mean, yeah, we'll talk about that in a second. I mean, Unicode. When you say a Unicode string, it's just a sequence of integers, like integer character codes, but the integers have a much greater range of values than ASCII. So, like if you know about ASCII codes, it's like the highest possible code is, like 127 if you're in 7-bit ASCII. When you go to Unicode, it's like the highest value is, maybe 65,000 or 1,000,000 or something.
I guess my real question what I want to know is there a performance hit due to the default being Unicode? If I read in a text file or write out a text file, am I going to take a performance hit because it's Unicode?
Yeah, so the question is there a performance hit? And it turns out that the answer is it depends. So let me talk about that. So it's actually a great segue into the next little bit here. Another question.
Question about the size of the Python representation of Unicode. Like, let's say Microsoft uses the name Unicode and it means 2 bytes. That's it. And then, like, if you want to represent in traditional Chinese, which has over this 2 bytes, that you are in trouble. So do you know if Python did it right?
I'm not sure I have the authority to say. So your question that you made. So there's one. I think your question is that there's a very large range of Unicode characters.
4-byte Unicode characters, or just 2 bytes?
So the question is.
I see the escape sequence for 4 bytes, so it looks like it is. Does it mean that whatever was taking 10 bytes is taking 40 bytes right now?
Yes. Well, let me talk about it. I mean, the question is partly about representation, but we'll get into that. So both of these questions actually sort of related to how Unicode characters are stored and dealt with internally. So one of the things that Python 3 has to do is, because there's this greater range of codes for characters, the storage requirements of strings actually goes up. So internally in Python 3, if you have a string like jalapeno, it's actually either stored as an array of 16-bit integer codes or as an array of 32-bit integer codes. Turns out that choice is a compile time option to Python. So if you configure and build Python from source, there's actually a configure option. I think it's like -- with wide Unicode or something. We'll turn that on. You can actually determine this if you import the sys module and find out the variable max Unicode. It will tell you what the maximum Unicode character value is, depending on how it's been compiled. If you come from C programming, by the way, all this really means is that characters are either stored as a short, like a 16-bit int, or an int as a 32-bit. That's all that's going on there. Now, as far as how this impacts performance, so got a question about that. Short answer is this: if you read text files in Python 3, memory footprint goes up. So if you're dealing with, like if you had a 10 megabit or megabyte ASCII text file and you just read it into a big Python string, it takes twice as much memory or 4 times as much memory, depending on what version of Python you're in or how you have it compiled. Question in the back.
The reason why Python 3 didn't store as UTF-8?
Oh, why it doesn't store it as UTF-8 internally? I don't know that I have like a definitive answer, but I think that text processing is actually easier to implement if the characters are left in like an unencoded state. Like if it was in UTF-8, every single time you did a string operation, like a search or a replace or anything like that, you would actually have to go through and decode the text to do that. It makes some other things more difficult, like slicing. Like if you were to take like a slice, do you have to like decode UTF-8 to figure out where that is and so forth?
Operations are exactly the same. Like if you look for a string, you're looking for the same sequence of characters.
UTF-8 is multi-byte though, it can change. Each character coding can be 1 up to 4 bytes.
Yeah,
so
that's it. If you're looking for any, you'll never be able to overlap.
But if you look from characters from 10 to 12, then it's not the whole thing.
You have to scan the entire string to reliably determine which character you can't jump into the middle.
I don't think you'll ever encounter the same. If it's in UTF-8, NA will be expressed as two characters, right?
Possibly.
Or single
No,
character.
UTF-8.
Or single character.
No.
Yeah.
No, UTF-8, NA will be expressed as two
ISO
characters.
89 versus is the same.
Oh, okay, because of the combination thing. Okay, yes, but assuming that the string comparison is going to be faulty and that this is getting a bit too much into detail, right?
Okay, yeah, I can't hear you very well in the back, but the short answer, I think, why is it not stored in UTF-8 internally is I think that the implementation of a lot of string ops would be significantly more complicated to deal with that. I mean, the ones that I can think of off the top of my head would be slicing, would be a little bit like tricky to deal with because you have to worry about like, well, did I just take a slice like in the middle of the UTF-8 encoding and then the sort of head would explode with that, but yeah.
Dumb question, how does it know it's reading fast? I mean, how does it know it's reading 8-bit or 16-bit or 32-bit when it's reading it? It's interpreting it.
Okay, well, we'll get to that in a second. So, okay. So this internal representation business, I guess getting back to that, it does have an impact. I mean, I'm not going to lie about that. I mean, if you're reading text, if you're doing just text data in Python 3, it has a much, either twice or 4 times the memory footprint to do that. One other thing about that is that it does impact runtime performance for certain kinds of things. So if there are string operations that do a lot of memory copies, actually one example, I mean, this is maybe a little bit contrived, but a slice is actually a really good example of like an operation that copies memory. So if you were to take a text string and then slice everything but the last character off, that actually makes a memory copy of the original string. That operation runs either twice or 4 times as slow in Python 3 because it's moving twice or 4 times as many bytes of data around. I mean, underneath the covers of that, it's literally just calling like memcopy in the C library. If you give memcopy 4 times as much memory to copy, it's going to take 4 times as long. So I don't really know like how you would like get around that kind of performance hit because you're essentially just shoving more data around behind the scenes. So that is something that is true about Python 3. The other thing that I'll follow that up with though is that some of the other operations are not affected and in fact actually might run faster. So if you do an operation like convert all the characters to uppercase, I actually found just in the test here that Python 3 ran faster than Python 2 on that. And I also found that regexes ran faster in Python 3 than Python 2. The reasons for that are a little bit subtle, but these operations like lower and upper and regexes and things actually process strings on a character by character basis. Like if you look at the implementation, it's looping over characters. And it turns out that processors, there's not really a performance difference between looping over bytes versus looping over shorts or ints. I mean, it's like the CPU is fine either way with all of those. And you just don't really take much of a hit. Maybe the one thing that you might see an effect of, since you are actually going over more data, you might have like slightly worse, maybe like cache behavior or something. But in terms of like what the interpreter is doing, you're not really doing more work there. So you do see that. And so just as a comment on that, this text processing thing is something that you probably want to study if you go to Python 3. I mean, certain operations do take a big hit, but other operations are about the same. So I can't actually definitively tell you that, oh, your program is going to run much slower in Python 3 or much faster than Python 3, because it kind of depends on what it's doing in the background. So that maybe partially answers some of the performance impact of this. Any questions about that before you do talk about this next bit? Okay. Well, the next little complication. Okay, so this, keep in mind in memory in Python 3, you do have this different representation. The other problem that you now run into is this encoding issue. And this is actually where this discussion of UTF-8 enters the picture. Essentially, the issue in Python 3 is that if you have some text, like the string hello world, if that's stored in a file as just ASCII, the file is just a bunch of bytes. Okay, so it's a bunch of bytes that represent that text. If that gets read into Python 3, there's actually a change in representation that takes place here. If you're using this 32-bit int for Unicode compilation, every single byte here has to get blown up into a 4-byte value when it gets read in. And the same thing has to happen when you write things out. Like if I were to write this back out to ASCII, I have to take these 32-bit integers and essentially cast them back down to byte values. So there is this problem that what you see in files is now almost never the same as what you see in memory. So memory and files are two totally different representations of data here. And then the other thing that you run into, and this is for all the the non-Americans encounter this more than we do here, is that there's like no one standard encoding of all the international characters. So for these non-ASCII characters, you have all these different character set encodings or data encodings that you have to worry about. What I'm showing here is how the word jalapeno is encoded in a couple of different character sets. So in Latin 1, it's an F1. In CP 437, which I think is the character set for DOS, if I remember right, it's A4. UTF-8, it's actually a 2-byte sequence, C3B1. UTF-16 uses 16-bit integers as character codes. Thing to emphasize here is that these codes that I'm listing here are more associated with files, like on disk. You would say, here's a text file. Oh, and it came from my mom's DOS machine in the basement or something like that. Happen to know that text file is CP437. I would have to know that to read that data into Python 3 and get it decoded correctly. So one of the things that happens is that all text that you read in Python has to be encoded or decoded. So anytime that you're reading text, you have to know what the source format is and turn that into a Python string. If you're writing text, you have to know what output format you want to put it in. And that's actually the major difference between Python 2 and 3 with text, is that there's now this encoding and decoding process that always takes place on the file system. Now I forget who it was that asked me, I think somebody asked, well, how do you know what encoding a file is in? That's actually a somewhat difficult question to answer in general. You may just know in advance, like either through like decree from management or something like that, that this file is in some format. There are certain things that are done in Unicode files to try and give you a hint. One thing that is often done in Unicode is, let me get rid of the character viewer here. Sometimes people will embed this Unicode character FE, I think it's FEFF or the other way around, where they take there's a special Unicode character known as a byte order marker that gets, what they'll do is they'll take that character and then write it into the start of the file, like the very first character. And then readers that read the file will look for that sequence of the FEFF and try to figure out, they can actually figure out based on like what it looks like, what the file encoding might be. So, so if you were to encode this as UTF-8, there would be a sequence of bytes, EF, BB, BF. So maybe a reader would actually look for that sequence in the first 3 bytes and decide whether this is, it looks like a UTF-8 file, or if it was UTF-16, you would get a different, actually that's kind of a interesting, okay. Okay, well, did I do that right? Okay, well, it looks a little bit fishy, but that's one thing that you do see done. Unfortunately, I can't really give you like this is a known problem that, if you don't know what the encoding is in any form, you may have to kind of experiment with it. Yeah, question in the back.
Just like for your information, there is a part of the Firefox project that has like a kind of code that has heuristics to determine the encoding, just like based on some patterns.
Okay. Okay, is that like a C library? So the comment is that there's there's a library or something in Firefox that tries to do this. Do you know how that's packaged? Is it something that we can use?
There's a port of this to Python by Mark Pilgrim called Cardet that's part of Feed Parser. I don't sound thrilled because it's just bad news. Just know, and if you don't know, ask. So if you look at the Latin 1 on the code page 437 data, either of those could have been interpreted in either character set.
Right.
So heuristics will fail sometimes.
You could just do what I do, which is I say I don't do anything with Unicodes. I just treat everything as either UTF-8 or Latin 1. And if it breaks, it's it works like most of the time. Yeah. Yeah.
Question about logging. Do you know whether the standard logging module produces ASCII text files, or does it produce Unicode?
I have no idea. The question is what output logging produces. I would guess that it's producing UTF-8 because that's actually the default that Python 3 uses if you don't specify. Or
your log files could become much bigger. Could become bigger than that.
All right. Well, let's just let's say a few more things about text. So this encoding thing, this is a major issue that you have to start thinking about. And this is actually probably the one place where a lot of programmers who don't do things with Unicode suddenly are going to have to start thinking about it, because you're going to start seeing these encoding operations taking place. One of the things that happens in Python 3, by the way, is that the open function for writing a file or reading a file actually has a new parameter available on it, encoding, where you can say, okay, I want to open some file, and the encoding is Latin 1. I'll actually say what that is in a second. And if you would omit the encoding, Python just assumes everything is UTF-8. So this UTF-8 encoding is actually the default that Python 3 assumes for everything. That encoding also applies to standard I/O. I mean, this is a little bit subtle, but if you're used to things like the sys.standardin or sys.standardout, those are now encoded data streams. So if you are doing I/O on those, there's basically Unicode encoding happening on those streams. One thing that's a little bit dangerous or curious about those, the encoding of standard I/O depends on what terminal you're using. This is actually something that I encountered in messing around with Python 3 when I was working on my book. So one of the things that I was experimenting with is, was this idea that's okay, I can have a string that has a Unicode character in it. So, I had S is equal to spicy jalapeno, and then in the interpreter, I could actually look at it and say, and it comes up, it says spicy jalapeno, and it's got the little tilde there. Turns out that if you switch over to maybe a different terminal program, like you go into X and you use an old school Xterm, let me see if I can make the font a little bigger on that, and you launch Python 3 here, and you do the same thing. Okay, so S is equal to jalapeno. If I try to view it, I'll actually get an exception in the interactive interpreter. This actually threw me for a loop the first time that I encountered this. So I'm like, why am I getting an exception just to view the value of a variable in Python 3? Turns out that what's happening here is that the encoding of sys.standardout is essentially set as ASCII. And I can't even view the values of variables in Python 3 if the terminal doesn't support the Unicode character set. So that was a little bit of a problem. There actually is a function called ASCII that will give you an ASCII safe representation of some variable. But that can actually sort of trip you up if you're playing around, just debugging stuff with Python 3. That the interactive interpreter might actually break depending on what the encoding is. I don't know. Like change it after the fact. I honestly don't know. We could try it. So you want to change like. I have a feeling that you can't. So, I mean, you could probably unwind it and like rebuild it with a different encoding, but yeah.
Or you could do system standard out equals, and God help you replace it, and then it might work.
Yeah, you could like do it with like equals and then reopen a file or something.
Yeah, the file you use is /dev/setup.
Yeah, I think that probably in violation of some Zen of Python law there. So that's something to know about. The other thing to know about, and we're going to get more into this in a second, is that Python 3 has really, really strict type checking with text and binary. One thing that you can no longer do is write text to binary opened files. So if you open up a file in binary mode, so you say open up foo.bin, WB, and then you try to write a string to it, it actually fails with an exception. And so we'll say more about that later, but in Python 3, anything involving strings explicitly has to have like a text file mode open. So if you try to violate that, you'll actually get a runtime exception showing up. And then as far as these encodings, let me just briefly talk about 3 of these. These are 3 encodings that I would say like non-Unicode hackers would tend to encounter the most. So I just want to describe what they are so you know. So this ASCII encoding is essentially text that's just 7-bit ASCII characters. So if you go outside of that range, you'll actually get an error. So that's what ASCII encoding is. A Latin 1 encoding is essentially just 8-bit bytes. It turns out that the values will come in unmodified. So if you just read like a file in this Latin 1 encoding, it actually is probably the closest to what you get in Python 2. It'll just read the byte values and then just translate them into Unicode characters with the same byte values. One little tip on this is actually the fastest encoding in Python 3 because it actually doesn't really do anything. So other than just convert bytes into a larger value. And then what UTF-8 is it's an encoding that represents all of the Unicode characters using 1 or more bytes. So it's a little bit subtle, but essentially ASCII takes up the first 127 bytes, and then you encode all of the remaining Unicode characters in the remaining bytes. So depending on what the character is, you'll get like 1, 2, 3, or 4 bytes after that. The fact that these take up multiple bytes is probably is one of the reasons why it would be difficult to work with this if this is what Python was storing internally in memory, because you'd have to work with all these like variable byte-sized characters. Now it's a little bit ugly to do that. So one feature of UTF-8, it does have ASCII kind of embedded inside of it. So if you're working with just like legacy, like ASCII files, it will probably work in a transparent way. And for the most part, it's a safe default to use if you just don't know. So like if you were writing out like a web page to put out somewhere, encoding it as UTF-8 is almost never going to run you into trouble. I mean, it's like most things recognize that. So, that is a pretty standard encoding. So one of the things to keep in mind, as kind of a summary of this, is that if you're coming from Python 2, you have to know that Python 3 does use this, this multi-byte representation of text. That does impact performance in certain ways. And then there's also this encoding and decoding business as well. Now, other than that, most of what you were doing in Python 2 should actually work. So if you're kind of ignoring Unicode, most of what you did before should work, except that you do have to be aware of this, this encoding and decoding business. So let me just pause for a second and see whether there's any questions about that. I'd actually like to kind of get out of Unicode into more exciting things, but it is something that you really definitely, definitely need to know about if you're going to Python 3. Yeah, question?
Do you know what 2 to 3 does? If in 2 you've been specifically encoding and decoding, does it just ignore it and assume it's correct?
Let me make sure I understand the question. So in 2, you could actually ignore a lot then.
Specifically encode when you open a file and decode and back and forth. If the 2 to 3 conversion tool sees that, does it just say, oh, I'm not going to deal with it, or offer you?
So I think if 2 to 3 sees that you're encoding and decoding, I would assume that it carries that forward, but I actually can't tell you like with 100% certainty. So, I mean, one of the things in Python 2 is a lot of people would use the codex module to do things, and actually I'm not really sure what Python 3, what 2 to 3 does for that either. I will tell you that this open function here, this Python 3 open is not the same as the codex open function in Python 2. It's actually a completely different function than what you would have used in Python 2. And we'll say more about that a little bit later. Okay, well that's probably enough about Unicode. I see a few eyes kind of rolling in the back there. So let me just talk about some other text processing things in Python 3 that are not specific to Unicode. So one of the things you know about is that print has changed into a function. This is a little mini porting guide just to sort of see how it's different. If you're just printing out items, just put parentheses around it. The dangling comma, you may know, to suppress the new line, that's gone in Python 3. Instead, you just use this end keyword argument where you can specify a different ending for what you're printing there. And then also the greater than F, that redirect, that's also gone in Python 3 as well. So all you do is you just say file equals F, and it gets redirected out to a file. What are people's opinions of the greater than F? Is it like a thumbs down? Is it a thumb? I actually admit that it didn't really ever bother me that much, but I actually find myself using it more than I would probably admit. But I'm pretty sure that I don't think Guido was ever really that happy with it. So, but okay. So that's gone in Python 3. And then a few other things. You can pick a different item separator now. This is actually a feature that I often get asked about when I do like an intro Python class. Somebody will ask, well, is there any way I can change the separator from a space into a comma or something? It turns out that that's really easy to do. You can just say sep equals colon or comma, and you can change that. And so that actually leads to some different programming idioms. Here's something that you might sort of think about. In Python 2, this is maybe some hack that somebody would do to print out comma-separated fields. Maybe you've seen code like this where you just say print, comma.join, and then just give it a list of the fields. You can sort of do better than that in Python 3. I mean, you can say print, name shares price, sep equals comma. I'm a little bit curious. I mean, I don't know. Does anybody have a thought about which one of those you would rather use in a program as like just a general programming idiom or reading the code?
Join makes more sense just
Yeah, I mean the join. Yeah, I mean maybe I'm asking the wrong.
The third one is neat. The second one is neater.
If I was, I'm actually surprised it's slower.
I would think it'd be faster.
Yeah,
that's what I thought too, and I don't know exactly why it might be slower. I mean, I don't know. Do you?
Yeah, I have a thought. I mean, doing all of your I/O to memory at once is faster than like hopping in and out, having your text data hop in and out of cache. Basically, bigger I/O chunks up to a certain size are better.
Actually, I think you're right on. Now that I think, maybe the second one would tend to write the different values in small chunks, like saying, okay, write the name, then the comma, then the shares, then the comma. So you may get like more sort of smaller I/O operations with that.
Well, I was kind of hoping that wouldn't have to do memory for the second case. I mean, I kind of just sort of took it for granted.
Yeah. So. I don't know. I think overall it's like a stylistic thing. I probably like the second one, but that's that. Another thing that's coming in Python 3 is this revision of string formatting. This one is kind of a weird one too. I come from C programming personally, and I have like this love affair with printf. You know, it's like I've used it a lot. I know about it. Python sort of takes the printf idea and does it with the % operator, and then all of a sudden Python 3 comes along and says, oh well, this is the way we want to do string formatting now. This is what string formatting looks like in Python 3. So you would say like 0:10s, 1:10d. It's like, whoa, it's like, what is going on with that? What's your initial reaction to that? Love it, hate it. What was wrong with the first one? What was wrong with the first one?
I don't pull up the man pages often with the new one.
So how do you
As I pull the man page.
The named parameters?
Name substitution.
Oh, we'll talk about it. All right. So they have this new string formatting. I think this is there's a little bit of history behind why this is showing up in Python 3. One of the things that you may know about Python 2 that's a little bit subtle is that string formatting was actually one thing that you could never customize. It's a little bit subtle, but classes and objects in Python 2 could define things like str and repr to change what their output was. But one of the things that they couldn't do is customize anything with that % operator. I mean, there was no way that you could, an object could make a custom code or do some, kind of custom thing with %. So one of the things that happens in Python 3 and 2.6 is that there's a new format method that gets added to objects. And what it lets you do is customize string formatting. So it turns out that there's actually 3 different string conversions that are available right now. You can either do an str, that's essentially what print will produce by default. You can do repr, which shows you what the representation is in the interpreter. And then you have this new format method where you can say, I want to format this, and then you can give it a format code where you can say, okay, like 0.2f or 10s or something like that. And what's happening here is this format is essentially taking the same kinds of codes that the % operator normally works with. So there is this new sort of special method that Python 3 gives you. And actually to go along with that, there's actually a new built-in function called format, where you can say format x as 0.2f, and it will create a formatted string that does that. This is sort of the kind of a partner to the str and repr function. So you have str makes a string, repr makes the representation, and format now makes a formatted string value. So some of the things that you can do with that is if you're, let's say you had some number. Okay, so there's number x there. If you want to just format that in different ways, you no longer have to do these things you don't have to use the % operator on that anymore. You could just say s is equal to format x. I want it to be 2 decimal places, and it would do that. So there's sort of this built-in function that does these single item formatting operations. And some of the nice things that they've built into this is they've actually extended a bunch of the format codes. There's a whole bunch of new stuff in Python 3 that you couldn't actually do before in Python 2. So if you want to do things like binary digits, okay, maybe that doesn't appeal to everybody, but if you wanted to, if you had a number x is 42 and you wanted to format x as binary, you can do a B method. If you had y is equal to 3.14 and you wanted to format that as a %, actually I did it with the wrong value. Y is a %, it'll come back 314%. I mean, there's sort of these new extensions that have been built in. There's some alignment things that you can do. Actually, the width and precision codes kind of get carried over from the old formatting, where you can say, well, format in a 10 width field with 2 decimal points. This alignment stuff is actually kind of nice. You can essentially use like a less than or a greater than or a caret to indicate where you want the field formatted. So if I were to say things like, format the value x, with within a 20 wide field with 2 decimal points. If I go back and put like a caret on it, it will center it in the field. Okay, so you can do things like that. Very nice. You could do that with the old string formatting, but there's a slightly different syntax for doing it. You can do filling. Just go through these kind of fast. So if you want a different fill character, you could say like this one. Format a number where equals the fill character, center it, and so forth. This is actually a new thing that is. I don't even think this works in Python 2.6 right now, but you can.
I'll justify and right justify, are those gone now, or are those still there? And they just.
Oh, the codes. I'm trying. So in the old formatting, it was like minus.
Well, there's also functions, right? String functions that do.
Oh, string functions. No, I think those are still there actually. Well, the string methods like LJust and I think those are still there actually. Some other things like this. This is something that's often requested to have like 1,000 separator. Between.
Biggest examples I have look at in courses.
How to do 1,000 separator?
Yeah, how to do it manually.
No.
These students just going to do one-liners. I got to stop them.
Yeah, I mean, if you want to do if you have a big number and you want to do that as thousands, you can just say format x. Actually, I think you can just say like comma d, and it will just do that. So you have to get a new example for the. For the class there, so I think that's kind of cool. I mean, it's like you have this this like new machinery available there. As far as I know, that is not internationalized, by the way. So like some places use a period as the separator. I don't think it does that. So if you look at that, I mean, you can see it's like wow, there's a lot of flexibility. There. One thing that I don't show here is if you make a new object and you redefine format, you can actually make your own format code. So you're not actually limited to like D and F or anything. You can actually make whatever format code you want. Yeah, there's a question in the back.
I think it makes sense that it wasn't internationalized there and instead defer that to gettext. Because you could gettext that string with the comma and have some libraries use dot and some use underscore. So I think it's good.
Okay. So you could like post-process it to do
the format.
Okay. So yeah, a lot of flexibility with that. And then just kind of moving forward, this new format methods of strings is also tied into this machinery. So one of the things that you have is instead of the percent operator, you now have this format method that looks for these formatting specifiers and curly braces. So what format is doing is it's going through this string looking for these placeholders in curly braces and then expanding those. So in some sense, each one of these like little curly brace pieces is similar to a percent code with the old string formatting. But what's actually happening here is that this new formatting is way more flexible in what it lets you do. So what's happening is each one of these specifiers sort of has 2 different parts to it. The part before the colon actually tells it what it is that you're formatting. So it actually refers to one of the arguments that got passed into format. And then this code after the colon is actually something that gets passed into that format method. So essentially what happens is each one of these things gets run through that format operation where it says, okay, format this thing, and that's the what, with whatever that code is. And so some of the things that you can do, I'll just kind of show you some examples of how this works. If you use numbers before the colon, like you say 0:10s or 2:10.2f, those are actually referring to argument numbers. So like the 2 here is referring to argument 0, 1, 2. So that's giving you the 9110. The 0 is referring to the ACME. there. There's actually no restriction on like how those are ordered at all. Like if you wanted to do 2 first and then 0, perfectly okay to do that. So you can kind of like mix up the order there. Another thing that you can do is refer to keyword arguments. So this is also kind of a nice feature. If somebody says format and you're saying things like name equals Acme, price equals 9110, you can actually use those argument names there instead. So you can say name colon, price colon, and it'll actually find those arguments and then sort of plug them in. If you leave off the name and you just say like colon, it actually gives you something that's similar to the old string formatting. It actually will just go in order that you specify. And then where you can actually take this a bit further, this might be the part of string formatting that will either increase or decrease job security, depending on how far you want to take it, is these references to objects here can actually do things like indexing and lookups. So if this stock was a tuple here, I can actually index that. Like I can say S bracket 0, format S equals stock. That is essentially doing like a tuple lookup on S, an index lookup on that and getting the value. Same thing can work for dictionaries. So if you have a dictionary of named values, you can do dictionary lookups where you can say things like 0 bracket name, and it will just look up that value. Yeah.
Well, what if you use the string 0 as your dictionary key?
That's a really good question. I think it will actually treat it as an integer. So yeah, I don't have that in that slide, but one restriction on these lookups is that it's actually highly restricted. I mean, it either has to be a number or an identifier. So you can't put things like mathematical expressions in there. You can't put, I don't think you can put names with like spaces or like non-identifier characters in there. So, it is a little bit restricted.
Members of the object.
Yeah, you can do. No, you can do attribute. This is what the next slide is. If you have objects and you want to do attributes, you just use dot. So you say 0.name, 0.price. So that's definitely something that you can do. And there really is, there's not really anything like this with the old, the old string operation. Really didn't have anything, quite like that. And then if you really want to make your head explode, there are ways to do like nested substitutions. This is I'm not sure how much I would advise doing this in like an extreme level, but one of the things you can do here is you can say 0 colon, and then you can make a reference to some other parameter in here like width. And then it will take that value and make it part of the formatting code. So, that's kind of a more advanced usage of that. Maybe you don't want to get too carried away with that because your code will become really hard to read afterwards. But it is something that's available there. Yeah, it's like the star in the old, like you could, the percent, star F or something. It's analogous to that. And then if you want to do a curly brace, I'll just mention that there is like an escape for that to put those in there. So as just some commentary on this, this new string formatting, I'll admit that I'm not really sure I'm comfortable with it yet. I mean, I'm too familiar with Python 2 and printf to like give it up entirely, but I can appreciate the huge power that's in this new string formatting operation. And I do know that they've threatened to take out the percent operator in Python 3. I don't know whether that's going to... My gut feeling tells me that there'll be blood on the streets if they take it out, but it is something that has been thrown about a little bit that that percent may or may not be taken out of Python at some point in the future. So I mean, probably this new formatting is something that you'll want to embrace a little bit. Just out of curiosity, I mean, what's your kind of take on that format?
2 to 3 doesn't reformat everything in the new format.
I don't actually know whether it does do the new format. I would guess that it keeps the old format. That would be my guess. Do you know on that, Wesley, whether it...
I doubt they're going to remove it because it works, right? It's the focus of 2 to 3 is to get unbrokenness.
Right. I mean, the one thing that bothers me a little bit about the new formatting is it feels very verbose to me in terms of like just the amount of typing that you have to do to do it. And every single time that I've used it, it seems like it's always ended up making this really gigantically long line in the editor. Like it's like I'll have this program where all the lines are nice and short, like 60-character lines, and then all of a sudden there's this print statement that ends up either going all the way out to like column 140 or something like that, or I have to line break it, across two lines, and it bothers me. A little bit. I mean, it just feels a little bit too verbose.
It's actually like a mini language.
Yeah, there's a comment on that too.
One concern about making it like a mini language, as just mentioned, or making it overly verbose, is that the target audience for strings is not just programmers; it's translators that don't code for a living.
Yeah, that's a really good point. So the comment is, a lot of people that would be modifying this are non-programmers. Do you think they would have more difficulty wrapping their head around this?
Yes.
This one?
Yeah.
So that's an interesting comment.
In the C world or something like that, they don't like changes in their cages.
I think this feature, I may be wrong about this, but this feels like one of the few Python features that has come from somewhere other than C programming. Isn't this what C# is doing with like composite string formatting? I don't know whether that was like the direct inspiration for this feature, but it wouldn't surprise me if that's where that originated. So, well, let me just do a quick check to see where we are in time to make sure that we don't blast through the break here. So we've got 10 minutes until the break. So any other questions about that before we go on? Yeah.
Well, just one thing I was going to bring up is I've used more and more of format now in 2.6 because when I'm dealing with someone else or we have very long strings, the example you showed where build equals 9 or build equals another variable that you previously assigned, it does tremendous things to make it very, very legible and much more readable.
Okay.
Simply for that alone, I use it.
I could see this actually being useful as maybe a replacement for template strings. A little bit. If you know about like string templates, the template object in the string library, there's this string where you could say, so maybe you have some big string. Okay, well. Okay, so you can have like you can have like a string like that, and then what you can do is create like a template string out. I should have done that. To begin with, you may know that there's this template object that lets you do, like substitutions across that, where you can say, s.substitute, and then you can fill in, like keyword, like values, and then it will go through and do like a dollar variable replacement. I could see the new string formatting as maybe like some kind of replacement of that. You could do. I don't know whether it's going to be quite as elegant, but you could imagine like you could have a string, and then instead of dollar variables, you could have, something like this embedded in there, and then you could do, s.format, and do some kind of nice, like nice keyword argument substitution on it, or something. Of that nature. So it may fit into that, into that space. And one thing I'm actually a little bit curious about, and I don't know the answer to it. I'm actually wondering if you forget, if you leave off the format code, like if you leave off the :s, does it actually work? I don't know. Actually, it does work. Okay, well, that's actually, I actually kind of like that. So in this example that I just did, I could leave off the the colon S, and now it's all of a sudden it's starting to look a little bit more like maybe something out of like a web template or something. So that's actually kind of it's kind of a cool thing going.
You're also not tied to sequence of the variables the way you are with the percent sign. I know it's good to generally do that, but you're not tied to it. You don't need to do that.
Right. The fact that you can leave off the code. Actually, let me try one other thing real quick. If you were to create let's just create a class real quick. You might be able to do a string if you had like a format string here. If you had something like that, you may be able to do like s.format. Well, the naming is a little bit unfortunate there, but let's say I had an f as foo.
You're missing some.
Am I missing? Oh crap! Okay. So I'm going to get a fail for typing here. Okay, so you might have something like that. There's my string. Okay, so now that's not going to work. But what you might be able to do is you could just say okay, let's create a foo, and then you could say f.name format f equals f or something. Okay, that does. Okay, that's kind of. It's kind of nice. It's like you can do these. You're referencing. Like attributes of objects. You definitely see like the tie-in between this and some of the web, like what some of the template people are doing. So that's maybe something that this new string formatting has going for it, is that there's a lot of these kind of interesting like new features of strings that you can actually start using there. Hopefully that wasn't too ridiculously fast to grok there. Did that make sense as to what's happening there? Okay, I like that a little bit. So what we're going to do in this next section, let me do a little quick time check. We're like 4 minutes away from the break. So let me just give you a little bit of a preview of what we're going to do when we come back, because we're going to shift gears a little bit. We're going to spend some time talking about bytes and byte arrays in Python 3. This is actually one area where Python 3 is radically different than Python 2. So one of the things that we're going to talk about is that Python 3 has this completely new byte string type, something known as bytes. And it actually has some really radically different behavior than what you might be familiar with. So one of the things that you can do in Python 3 is you can say, I'll give you a sampling of this before we go to break. You can create a byte string. You can say s is equal to b. You preface it with a lowercase b, which is kind of like the byte version of the u that you had in Python 2. And this creates an object of type byte, so it's this byte string object. But it's a really kind of an odd sort of object. One of the things that's a little bit odd about it is indexing. Like if I were to pull off the first character of the byte string, I actually get a byte integer code. It's like, okay, that's a little bit odd. If you loop over a bytes thing and print things out, you no longer get characters, but you get integers. So you're like, well, that's kind of odd. Some other things that you can do is there's different ways of constructing bytes objects. So you can say, okay, I want to create a bunch of bytes from a list of numbers. You can do that. If you want to create like a bunch of padding bytes, you can say I want like padding is equal to bytes 20 or something. It gives you a 20 length string of 0 bytes. It's like, okay, that's a little different. If you want to create like bytes from like a bunch of hex digits, And I'm probably missing I'm missing like one of the characters there. You can do things like parse like sequences of hex numbers with that. So when we come back, we're actually going to talk more about what in the world is going on with this bytes type, because this is very different than Python 2. And then we're actually going to talk about the re-implemented I/O stack. So there's actually quite a few sort of interesting things going on with how files are handled and how system interfaces work as well. So that's what we're going to do when we come back. And I think 2:50 on the break. So we'll come back in about 20 minutes.